Perfect. So hello, everyone. Nice to meet you. My name is Hailey D'Silva. I'm a solutions architect with Amazon Web Services, or AWS. My background is actually in imaging research. So I worked for about 10 years in the research space before I joined AWS, most recently as a neuroimaging data analyst at the Yale School of Medicine, where I was building neuroimaging analysis pipelines on AWS using data from a large multi-site national study, the Adolescent Brain and Cognitive Development study. So it's my pleasure to talk to you today about, we're going to talk a little bit about what is AWS and how do we work with scientists. The main point of today is talking about the registry of open data and how imaging scientists are using that to scale their data to a public audience of the scientific community. And then third, we're going to speak about how imaging scientists use AWS to scale their work and accelerate their time to science. So first, a show of hands. Who is familiar with AWS in general, like at a high level, understands what we do? Okay, awesome. So many hands around the room. And then who has used AWS in their work? And a few hands. Awesome. Great. So for those of you who are unfamiliar, separate from Amazon as the retailer, we have a cloud computing division, and that's Amazon Web Services. It was actually based off of some of the scalable practices that we had from supporting the retail website that we started the cloud computing division. And so AWS is a large global cloud service provider. Cloud computing is the delivery of IT resources over the internet on a pay-as-you-go basis. And essentially what the idea is that, for your large research projects, you would typically have to, if you were doing it on premises, you would have to decide, okay, you need a certain amount of GPUs or compute capacity, you need a certain amount of storage, so you need to plan that ahead, you need to provision all of that. Usually that's a process that takes weeks to months before you can start your project. Versus with AWS, you are able to spin up those resources very quickly and be able to perform your work. So AWS has a global network. We have 38 regions around the world and 120 availability zones, and that's a number that just keeps growing. All of these regions are also connected by the AWS backbone networking. Our availability zones are clusters of data centers, and then the regions are clusters of those availability zones. In Canada, we have two regions. So we have one right here in Montreal, and then we have another one that just opened up a couple of years ago in Calgary. I'm from AWS Canada, so this is incorporated in Canada, and we have 40,000 employees in Canada across 65 different corporate and logistics sites. AWS protects many of the most highly protected and regulated data that exists. So think about data from banks and hospitals and governments trust us with their data. So security is very important to us. It's actually our #1 priority. And we have 143 different security standards and compliance certifications that we can support, including GDPR and HIPAA High-Tech, SOC, the Canadian Centre for Cybersecurity Protected Medium Profile, and many, many others. Because of my work in research, I work a lot with academic medical centers and research organizations across Canada who are looking to use AWS to scale their work. And oftentimes the conversation starts with talking about our GPUs and storage. And absolutely, we can have that, we can provide that access, but they're often surprised by the ways that we work with research beyond that. From a technological perspective, we have services that are very similar to the types of the services that researchers use on premises. So we have a service, for example, that can launch an HPC cluster within a few minutes. We have services for AI/ML development that has sort of an umbrella of a number of tools that will help you with AI model development, training, and inference. And then beyond the technology, we also have a number of ways that we are also working with researchers to do things like writing letters of support, for example, for researchers that are writing grants that have a cloud-based component. We also have training programs for researchers. There's actually a self-paced training program that's specifically designed for different tracks within research to help enable them on AWS services. We have workshops that we do with research teams, and then we also do co-publicity for things like speaking at conferences and events, or publishing blog articles together, or creating reusable code assets. One of the ways that we are working with researchers, and is the main point of my talk today, is our open data program. So open data can be defined different ways by different people, but the way we define it is data that is freely accessible to as many people as possible. So freely in that there's no subscription service, there's no like paywall in front of it, and available to as many people as possible. Generally speaking, that means that the data is fully publicly available, although we do have data sets that are not fully publicly available. There is some controlled access. For example, genomic data sets are examples of data sets that is not completely publicly accessible, but given the nature of the data, is open to the scientific community. And we have AWS users that are on both sides of this. So we have users that are data providers that have these large data sets that they want to make publicly available. And we also have data consumer users who want to be able to access that data and use that data in their work. There's two parts to the Open Data program. The first is the Registry of Open Data. So this is our collection of the data sets. We started with Landsat data from NASA, so the satellite imagery, and we've expanded now to over 800 data sets and 300 petabytes of data. We have data sets that span a range of scientific fields. So we have NASA satellite imagery, we have geospatial data, we have life sciences data, medical imaging, genomics. So a really large span of the data. Each data set also has usage examples and tutorials to help you get started with working with the data. You can access the data from the service that's used is AWS S3. This is simple storage service. It's one of our most commonly used and highly scalable storage services. And then you can also, it's integrated with SNS, which is a notification service, so that you can get updates about changes to the data sets, as well as integrate those changes into your workflows in a programmatic way. And then, of course, you can then work with the data using our compute services and AI/ML services, and so that you are bringing your computational tooling up to the data. Oh, 2 minutes. Okay. I'll try to go quickly. So we have 200 data sets for life sciences in the Registry of Open Data. Here I have our imaging modalities. We have functional MRI, anatomical MRI, digital pathology. I'd really recommend that if you're working with an open data set, that you see if it's with the AWS Registry of Open Data, because there is a good chance that it is. And then the other thing that is the second part of the program is the sponsorship program. And this is where AWS will cover the costs of the storage of the data and the data egress fees for high-value data sets. It is an application process, and I'm going to have a QR code with that application at the end. There's some requirements to it. The data there's no paywall. It has to be free and open. Yeah, so you can take the QR code or talk to me afterwards if you'd like to be put in touch with the life sciences program manager. And then I finally I have 1 minute, so I want to leave you with just a few stories of how institutions have used AWS for collaborative work. So the Allen Institute, they have their Brain Observatory in our Registry of Open Data, but we've also worked with them over the years on a number of different projects, most recently on the Brain Knowledge Platform. And this is a platform that is to study 200 billion cells of the brain. It brings together multimodal data from omics and imaging and electrophysiological data all in one place. There's Gen AI tooling for natural language querying of the data. There's a research portal that is collaboration space for researchers where they can work with the code and the data and a compute environment all in one place. As well as Radboud University in the Netherlands uses AWS to host their Grand Challenge platform. And this is a platform that allows AI scientists to work and compete on their AI algorithms. So some of this data is from the Open Data program, but some of it is where institutions host their data privately. The AI scientists are able to apply their algorithms without having access to the data. And then on the other side, the AI scientists are also not sharing the IP of their algorithms, but they're able to compete to see how well their algorithm does compared to others. So with that, I will put on the QR code. If you're interested in the Open Data program or AWS, please let me know. And thank you to the institutions that have shared with the Open Data.